Hey y'all, it's Miss Chester, and this is the Screencastify for our Chapter 19 on fossil fuels. It corresponds to the College Board's Unit 6, at least part of the Unit 6. I wanted to go over just where everything is in person. If some of you guys are watching this or doing the Ed Puzzle, hopefully this will help you with your organization and systematizing how you're going to independently study and get through this unit. Of course, I am going to be available in tutorials, office hours, in class, and in all likelihood, we will be working more one-on-one as we go forward so that I can help each of you individually. And I believe I've already communicated that at this point, but I want to make sure that you guys know that I am available. I'm working on your behalf every day. It is different and surreal and a bit exhausting. And so I hope that you are feeling the same way that I am, not exhausted per se, but looking forward to this upcoming holiday weekend. I know I certainly need it, but one of the things on my list to do before we got there was make sure I had something up for you guys so that you can continue your studies. Okay, so the first thing I want you to notice, and we're obviously looking at the period 1 APES class, is the only thing due for me right now is the mastering that goes along with chapter 19, and it is not due until Tuesday, April 14th, and I gave you till 5 o'clock. So even if you haven't gotten done with it yet, or you didn't want to do it until the Screencastify and the guided notes were available, you should have plenty of time between now and even Tuesday, using the whole day Tuesday if you need to, so that you're not working too much over the weekend. As always, if I'm pressing you too fast with deadlines, then you just reach out to me individually and I will work with you and we will make something happen. So don't worry about that. Um, I am going to turn the Screencastify that I'm currently making into an Ed Puzzle. And for those of you that watch it and watch it through the Ed Puzzle site and answer the questions that I will put with it, you will get some extra credit so that your grade can go exponential. I don't know completely exponential, but can definitely, you can gain some more points on your average more quickly than if you just do the mastering assignment, okay? So that's what's going on right now. You will notice if I move down to review materials here, I have now put up for you the Chapter 19 lecture PowerPoint, the guided notes, and we're going to look at both of those in this Screencastify. And I went ahead and attached both of the links to the edX courses that I think could be useful to you between now and the end of the course if you, again, want to do something different than Ed Puzzles for extra credit, or if you're just interested in auditing a course from Dartmouth or from Harvard. So this course from Dartmouth, for instance, I took this course back in 2015. And if you notice, like if you open up the screen, it's not going to look like this for you yet until you make yourself an account. Obviously for me, it says resume course because I've already taken this course, but there are 6 units. Notice that the week 4 and week 5 on non-renewable and renewable energy are really, you're attacking the information from a different way, but it is the information that we're doing in the College Board's Unit 6. The instructor for this course, Dr. Friedland from Dartmouth, has written a really popular AP Environmental Science textbook. So I thought that this course was a good one. The other course that I'm actually going to enroll in over the weekend and start working through is a course offered through Harvard. It is being offered currently. I think they started offering it in January. Again, I'm auditing this. There aren't tests associated with it. It's just learning for intellectual curiosity. But I'm interested in this course because I think that it will be realistic in the environmental constraints that we have with energy, and talk a good bit about renewable versus non-renewable, like how we're going to run out of non-renewable resources, but how we need to implement more renewable resources, but getting that to work with the socio-economic, political agendas, both nationally and worldwide. It should be interested. So I think I'm going to have fun taking this course. This is not a command performance. You do not have to do this, but if you're interested in this kind of thing, and this wouldn't be horrible for you, I can absolutely associate you or give you some extra credit for working on this type of thing and going over and beyond what may be in your textbook. Okay. The other two things obviously are the PowerPoint and the guided notes. So let's kind of get into those. Let me show you what I did with the guided notes. Okay, so with the guided notes, I want you guys to understand that in the With Got book, chapters 19 through 21 are about renewable and non-renewable resources. And the book covers non-renewable resources and the impacts of fossil fuel use, where they come from, how we turn fossil fuels into electricity, energy in all forms, and then talks a little bit about conservation at the end. I put a quick reminder here about chapter one, just the difference between renewable and non-renewable natural resources. And while that isn't directly energy, it pretty much relates. And when I was meeting with you guys one-on-one, most of you could give me non-renewable energy resource being, um, coal or any type of fossil fuel, whereas renewable, solar, wind, all of those things. You guys know that at this point. But now we're going to get into it a little bit more from an energy perspective. Now, when I did the guided notes for this section, I went ahead and kind of correlated it with the College Board's topics, 6-1 through, I think they're through 6-13. And if you can see here in orange, okay, I put all the different topics that are covered in this particular unit, 6-1 through 6-5. And actually, there is a topic on using biomass, which is like basically the burning of wood and other biological components for energy and heat. And I could have put that in here too, but I'll hit it a little bit later since I didn't put it in these original notes. But 6-1, pretty self-explanatory. I think we already knew that. 6-2, okay, notice that on 6-2, anytime I want you to go to the With Got book and look at various figures and so forth, I put them there. So for instance, if we went over to 19.2 in the textbook, let me present this. Ooh, let's go. Come on. 19.2. There's 19.1. I think that this is 19.2. It just shows the consumption of energy over time. And you notice that's gone up, whether we're talking about oil or coal or natural gas. Talks about some of the table 19.2 talks about the varying regions that have the most reserves of fossil fuels. And I think that this is an important graph for you to look at, or table for you to look at as well, because the natural resources that we have in our given countries are almost like wealth or worth. And so when you think of some of those countries in the Middle East, Saudi Arabia, Qatar, in the United States, Brazil has a good bit of natural gas, or even natural resources from rainforests or whatever. We've got a lot of our wealth is determined on the natural resources that we have and extract. And the extraction that we do, if we deplete our lands of those natural resources, then we ultimately will deplete our wealth as I think when we're looking back at what is topic 6.2, the uneven distribution of not only fossil fuel reserves, but also thinking about the uneven distribution of energy as it's used across varying countries, you can see here that there are some countries that have a very large footprint and are using a lot of energy compared to others who don't use energy. So I think that that's something to think about. So I just want to, let me flip back over right here and you can see, okay, so we looked at figure 19.2, figure 19.3 showed the geographical map of energy consumption. So I kind of have the notes and the PowerPoint for you to kind of flip back and forth between the notes, the PowerPoint, and your book. Everything in green, these are the bullet points as guided for us by the College Board. And we can talk more about those even in class if there's one that you don't understand. Um, when you look at 6.3, you notice I've got what the topic is from the College Board, green from the College Board, and then anything that goes along with your textbook, kind of where you would go to get more information. I did pull some information on peat because I didn't think that you guys likely knew exactly what peat was, but if you want more information, go ahead and open this little um, link from National Geographic that's hyperlinked for you there and read a little bit more about that. Some people will say there are 3 types of coal. Others will say there are 4 because peat is, kind of the 4th source of coal. It's just the one that's closest to the surface of the earth because it's just partially degraded organic material that many people will use and burn as a fossil fuel. But as you go deeper and deeper into the earth, you get different types of coal, lignite, bituminous, and anthracite, depending on how deep and the depth changes the amount of heat, pressure, and how deep it's buried. Basically, just different types of coal. And there are different ways that we extract it depending on how deep it is. You see, lignite is the one that's the closest to the surface, and then bituminous coal, and then anthracite. Your book also has information about all three of these, and there's a couple of figures in your book about the different types of coal as well. But notice that in this fuel types and uses, knowing what peat is, knowing the three types of coal other than peat, understanding natural gas, crude oil, and then how the different types of non-renewable resources are turned into different fuel types is important. So let's flip back over real quick and look at where we're going to find a chart about that. So I think that this particular chart right here is one that you might want to spend some time with, um, simply because you have to understand that whether we're turning oil, natural gas, or coal, those are our non-renewable resources that have to go through processing to give us the energy that we need for driving our cars or flying our planes or running our trains or whatever it might be. And truly look at the percentage of energy we use versus the percentage that's lost to heat. Okay. Remember, whether we're talking about the law of conservation of matter or the law of conservation of energy, matter can be neither created nor destroyed, and neither can energy, but it can change form. And when energy changes form into heat, it's no longer usable for electricity. It just increases entropy or increases the disorder of our atmosphere. And so we can totally talk more about those things if you are having trouble spiraling that. But at this point, I think with the science that you have behind you, you probably understand those bigger picture concepts. And if you are having trouble reading these pictures in the book, then yes, we need to meet some one-on-one and make sure you're understanding what these types of graphs and figures and pictures are telling you, because that definitely will make a difference in your understanding. Okay, and so also when you get to crude oil, the whole case study about the Alberta oil sands and bitumen, which you might not be familiar with that type of energy source, you can read through that and hopefully gain more information about what that is and put that into your knowledge bank, or at least the notes that you're going to use to take the AP exam a little bit later. When we get to 6.4, we talked about this a little bit earlier, and we already looked at figure 19.2, but the distribution of natural resources is not even across the globe, just like the distribution of energy use is not even across the globe. And your understanding of both of those is going to help you with the big picture. 6.5, I think, is really, I think you're going to need to spend the most time maybe on 6.5, kind of looking at how fossil fuels are combustible using turbines, generating heat, generating steam, generating heat, generating electricity. So figure 1910, we'll look at that in a minute. And then how we extract those fossil fuels now that we're running out of like the low-hanging fruit, the easy coal, natural gas and oil that we can get. What are we having to do to extract what's left? And what are the environmental implications of that? You can think back to the documentary we watched with Gasland with fracking. Is that a good idea? Is it a great idea for us to continually reach deeper and deeper and deeper in different offshore drilling or lands that we haven't touched yet, like all the boreal forest and things up in Canada and in the upper United States? There are lots of places where there is still oil and natural gas to be extracted, but what are the environmental implications of that, as opposed to thinking about ways to either conserve energy or ways to up the amount of renewable energy that we're using compared to the amount of non-renewable energy that we're using. And the book definitely changes in 19.4, 19.5 to talk about, okay, how is our fossil fuel use impacting the environment? And then what are we doing with regard to energy efficiency and conservation? And then you're going to see in the next couple of chapters that there will be lots of information about renewable resources that we can use for energy, nuclear, wind, solar, geothermal, all these different things. And so in this unit, primarily we're trying to get clear in our head what fossil fuels are, what non-renewable resources are, how we extract them, how we get them from the point of extraction to the place where we can use them for energy, electricity, whatever it might be, and what the environmental impacts are to us because of the extraction, and what will continue to be further and further environmental implications if we continue to extract what's left, which is harder to get into, harder to get to, and we don't get as much return on our investment. Now, the EROI, let's go back to that really quickly. Your book talks a little bit about this net energy and EROI, energy returned on investment. You do not see this term specifically, and what the College Board gives us is the points you have to know. But ultimately, this is kind of an economics term, so it bridges between economics and environment. If it takes us not much energy to get the low hanging fruit, the oils that we can convert to electricity, and we get most of the electricity out of it, there's a lot of bang for our buck. But if we've got to spend more money, like if for every dollar we spend, we only get like 15 cents of energy out of it, does that really make sense? As opposed to if we spend a dollar, do we get 85 cents of energy? That type of thing. So ultimately they're looking at ratios. I think understanding that is not a bad idea, but it's just not explicitly mentioned in the College Board. Other figure that I wanted you to spend some time with is I definitely think that you need to have an understanding of how coal gets pulverized, heated up, makes steam, turns a turbine, and then generates the electricity that we use. You have to have a general understanding of that. And you have studied that before, I'm sure. For some of you, that just is like, Miss Chester, I've known that since I was 10. But for others of you, really understanding how we burn fossil fuels to generate our energy, to turn on our lights, to turn on our hair dryers, to cool our refrigerators, make our air conditioner work, whatever it might be. Sometimes we just assume that it just gets there magically, but that is not the case. And so I think it's important for you guys to understand that. Okay, so I'm going to sign off for now. I hope that what I have said here has helped you kind of collate and think through how you're holistically going to work through this unit. But this is just a starting point. There's work for you to do, and I can help you do that work as soon as you can get into the material, which I know you already are, and help me understand where you need more information from me as far as answering your questions and so forth. So I do hope you guys have an excellent weekend off, and I will be available to you the rest of the day today, which is Thursday, and then again on Tuesday, and I'll be sending you an email about what exactly we'll do in class. So have a great day.